Hi guys, and welcome back to the Python track. This is officially the end of the track. This will be our last lesson, and we are going to be on lesson 12, which is the final lesson, and we're going to be talking about modules and packages. In the previous lesson, lesson 11, we talked about dictionaries. So we basically covered all the data types like strings, tuples, integers, numbers, dictionaries, and lists, right? So pretty much covered all the data types that you need to do any program in Python. So today I want to talk about modules and packages. And I think we cover modules a lot this during the track. We covered the total graphic modules. So you kind of got an idea what a module is. We imported Python's very built-in libraries and packages that Python already pre-built into its interpreter. And all we have to do is import it into our code, and Python will recognize the module as long as it's a built-in module in Python. It will recognize it. Otherwise, we'll get an error back that's saying this module is not recognized because maybe it's not built in. But anyway, I think you guys know what a module is. So this is a big. That was like I went a little clips about it, like in like pieces and stuff over the last couple of lessons. So this one is going to be talking more about details of what modules and packages are in Python. So without further ado, let's just jump right into the lesson. So what are Python modules, right? So we covered this a lot throughout the track. So I'm just going to go through these bullet points and I'll explain them. What they mean. So files. So Python modules are files with previously written code that can be imported to the Python interpreter. Meaning the total module. Let's take the total module, graphic module, right? We import total, right? Before we do when we want to work with total, we import the total module. So we say import total, right? And the Python interpreter recognizes total, right? So whenever we use total in our code, it knows because it knows what total is because we imported it. It's already a built-in package, or it's already a built-in library in the Python library. So it's a good thing to know modules a lot. Another module we talked about the math, right? So if you want to use like pi or square root, you import the math module, and Python will recognize that, and it'll take out all the features from the math module, right? So the math module contains pi, square root, square, all the math operations, right? So whenever we want to use any of those special math stuff like square root and pi and stuff, we use the math module and we import it. So that's basically what that first bullet point is trying to say. Also, a module can contain its own public and private variables to prevent interfaces with user-defined ones, right? So it has already a pre-built module, right? So what we write as the user, Python couldn't distinguish between the two, the built-in one and the ones that we try to create ourselves. When we use like classes, right? We create our own like class, right? We create like our own packages and stuff. So that's kind of like what it means. And again, all Python modules must have the py extension, right? So whenever we want to name a file into the directory, we always say, whenever we save a Python file, we always say .py. And we've been doing that with all the files that we've been doing in Python, right? We save it as a .py file, and it gets saved into a folder, right? And that folder is like a directory, right? And you have to save everything in that folder so Python could collect everything from that specific directory. So how do we import modules? So it's pretty straightforward, right? Let's say import, right? We use this when we use total, we import total. It's a module in Python known as modux, right? And modux.cube6, right? And then it's basically showing what cube of six cubed is, or what that is, right? Cube of 6. And when we multiply 6 times 6 times 6, right? It's basically giving us 6 cubed, right? And 6 cubed is 216, right? And you go ahead to do it this way. You can set it as a variable, right? So let's say the variable is y equal to mod x dot cube 6, and then we want y, and it will still get us 216. So Python knows what mod x is once it's because it's a pre-built-in code in the Python interpreter, right? So the interpreter knows what mod x is. All we have to do as the user who's writing the code, or the programmer who's writing the code, we just have to say the word input. Same thing with this one. We can use the from statement, right? From mod x import cube, find the cube root of 3 cubed, right? And when we say cube of 3, it recognizes the mod x, right? So we can use the cube. We don't even have to say mod x because it's from mod x, right? And mod x, we're trying to find the cube, so we're trying to find the cube of 3, which is 27, because 3 times 3 times 3, 27. So that's how we import the modules in Python. We just say import, and we had a little bit of preview of that when we worked with classes and the total graphics, right? We imported modules into our code. So execute modules as scripts, right? Python modules can be executed in a command line like this, right? Python modux.py, and modux is the name of the module we're using, right? But you can use any module here, right? .py and the argument, right? That we want to pass in. So this is how we can execute as scripts too. Compile Python files, right? So when importing a modux.py, it automatically generates a PYC file, right? It's generated automatically once we import that module. It contains the bytecode from the last time from modux.py when we imported it. And if there's no .pyc file that exists, it will be Python will automatically create it once we import the module, right? And for future imports, these .pyc files are used to speed up the load time, not the execution time, right? So it doesn't have anything to do with the runtime of the code, right? It's more about the speeds up the loading time, and not about the runtime, how efficient your code will be. It's not the execution time. So don't get confused between the load time and the execution time. Now here's a big function that I wanted to show. It's the directory function, right? So functions return a list of modules. This function returns a list of modules and the function that have to be imported, right? So it just gives you a bunch of modules in that directory, right? So let's go, when we go into the shell, right? The Python shell, not the file, but the shell, right? With these 3 arrows, right? And we type in this directory, dir, and the 2 parentheses, we get, like, let's say we get a module, let's say we get modules that contain these items, right? It's a list of these 2 items, right? It contains a list of the module name and the module package, right? But now, what if we want to add something else to that list, right? We want to add another thing, right? We import it, right? So simply just say, let's say we want to import modux, right? When we were looking for find the cube of each of the numbers, like 6 cubed, 3 cubed, right? What we used was the modux module, right? So how we could add it is just say import modux, right? And then again, once we import it, on the next line, we just type in the directory function again, dir, with the 2 parentheses. And now we're going to get the same list again. But look at this time, we're going to have the modux added in there because we imported it into that list. So we have name, package, and the new one that we just imported, modux. So that's a good thing. When we're not sure if the module is imported, we use the directory function because we want to check if that's in the directory or not, right? So if we're not 100% sure if this module is already imported to the directory, we use the directory function. And in this case, we imported it, modux, right? We want to check if it was added into the directory. So we just hit the directory function again. And again, like we wanted, it was added. So we know the modux module is added into the directory. Standard modules, right? So Python comes up with a library of standard modules, right? And these modules contain built-in operations that are not actually part of the Python core, right? So these standard modules are not in Python, but outside of the Python, right? Outside of Python, outside the interpreter, outside of Python, right? So let's say some of them are only imports based on the operating system, right? For instance, WinRag, right? Module is only provided on the Windows system, right? It's not a Python module, it's a Windows module. It's only provided by the Windows operating system. And an important standard module is sys, right? Sys.sys, right? And it's used to change the search of the path of the module. So this is a powerful module, standard module, sys.sys. It's used to change the search path for the module. So it's a very important standard module. Again, you don't need to know so much about it. It's just a little fact that I want to throw out there. Okay, so we talked about modules. So now we go on to packages, right? And what packages are they are an organized collection of a bunch of modules, right? They're like a bunch of modules, and they're like organized into a collection, like a package, right? So think of a package like we get at a when we order ports online, right? Let's say we order ports for a bathroom, right? We order the pipe, we order the other tools, right, that go in there. And when the delivery man delivers it, it delivers it in a package, right? All those ports are in one packages. So those ports that we order are like the modules, right? So we could think of it that way. That was just a little analogy I wanted to throw out. So modules are stored in directories, right? We talked about directories. Directories is where you save all your files, right? And you name your directory. So whenever you want to pick up that file, you always have to be in that directory for Python to recognize it. If you're not in the directory, it's going to throw back an error because it doesn't recognize that file because you didn't say you're not in the right directory. You saved the file in a different directory. So modules are stored in directories, and each directory contains the int.py file, which tells the Python interpreter that is a package directory, right? Whenever they see the __int__.py file, it tells the Python interpreter that directory is a package directory, right? It's just that's how you could distinguish how Python interpreter distinguishes a regular directory from the package directory, just by looking at a file, the file __int__.py files. And you'll know that a lot once you start doing coding and stuff and working with files. You'll understand that that's going to be a big case. I didn't want to go into files in this track because I think it will be a little too complex to think about it. But once you guys get the hang of the basics, we could talk about files, and I'll show you how that works when we write a file and then we want to print out to an out file, right? So we write an in file and an out file kind of thing. Here's some examples of packages, right? Here's the math. This is the path it takes, right? So this is an example of a package. It contains the int, right? Always contains that file, like I said in the previous slide. Every directory contains, or the package directory always contains this file. So that's the first file we contain. And then we create another file called try square area, right? And this is all in the statistics package, right? In the math package, right? And then here's the statistics package, right? This is the math package, right? And now we look in the statistics path, right? In that package, and we have again the int file and another file we created called mean val, right? So this is in one. This is one package. This is another package up here. Examples of using packages, right? So let's say we want to import math.square area, right? So now we're just finding the area square, right? Just an area of a shape, like a square, right? So we say math.square, right? Area, right? That we call that package, and we call that file, and we call the area command to it, and we pass in 5, right? So what's the square, what's 5 squared? It's 25, right? And from another thing, we could say it's from math.square area import area. We could do it that way. Again, pass and get the area command, pass in the parameter 5, and we'll still get 25. So this is how we could use packages when we in Python. Some straight two ways we could do it. This way or this way. Same thing. So that's how we could use packages in Python. And I think that was the end of the presentation. That was like a really brief introduction, not introduction, more like a good summary of what packages and modules are in Python, right? It gives you a good idea, and it will help you in future tracks. So this was like the end of like a really basic understanding of all Python concepts, right? We talked about so much throughout this track, so I hope you guys really understood it. And again, if you need to rewatch the videos, they're always going to be posted on gencode.us. Also, they will be posted on the YouTube channel. And if you have any questions, you always email us at gencode.us@gmail.com, and we'll answer your questions. Even go live stream with you, right? If you really want to go understand something, if you had a problem with a code or a problem with something, you can always get in touch with us via email, and then we can always set up a Zoom meeting, and we could talk about this stuff one-on-one, right? If you want to get that close and understand what it is, we could set up a Zoom meeting, and we could do a one-on-one session to help you understand what that video was trying to understand. But I highly recommend watching the video first. Try to understand this stuff on your own. And if you're stuck, obviously, if you're gonna be stuck, you get in contact with us, and we'll try to reach out to you, and we will do the Zoom one-on-one session, and that will actually give you maybe a better understanding, maybe that way. So I hope you guys really enjoyed it. I loved working with all of you on this track, and I hope you really became good with Python, right? Understood all the good topics, and I hope you became experts in Python. So without that said, I'm gonna sign off, and I hope you all have a wonderful day, and thanks for tuning in to the Python track. Have a nice day.